Hello everyone, welcome back to the channel. Fire Protection System with Zishan. Today, we are going to learn about Indian standards, commonly known as IS standards, which are developed and published by the Bureau of Indian Standards, BIS. IS standards play a vital role in ensuring quality, safety, reliability, and uniformity in products, construction, engineering, firefighting systems, electrical installations, and many other industries across India. In this video, we will discuss some of the most important IS standards used in India for fire protection system, their applications, and why they are important in day-to-day engineering and industrial practices. So, if you want to improve your technical knowledge and stay updated with Indian codes and standards, make sure to watch this video till the end. Let's get started. First, let's understand IS 15105:2021, the Indian standard titled Design, Installation, and Maintenance of Fixed Automatic Sprinkler Fire Extinguishing Systems, Code of Practice. This standard provides detailed requirements for the design, installation, testing, commissioning, inspection, and maintenance of fixed automatic sprinkler systems to ensure effective fire protection and life safety. On the left, we can see various types of sprinkler heads. These are heat-sensitive devices designed to operate automatically when the surrounding temperature reaches a predetermined level. An important feature of sprinkler systems is that only the sprinkler closest to the fire activates, allowing water to be discharged directly onto the affected area. In the center is the alarm control valve, one of the most critical components of the sprinkler system. It controls the water supply to the sprinkler network and initiates alarm signals whenever a sprinkler operates, providing immediate notification of a fire incident. On the right is the test and drain valve assembly. This assembly plays a vital role in routine inspection, testing, and maintenance. It is used to verify proper water flow, check alarm operation, and safely drain the system when necessary. Together, these components work in accordance with IS 15105 to ensure reliable fire detection, alarm activation, and fire suppression. Compliance with this standard helps improve life safety, minimize property damage, and maintain the overall effectiveness of the fire protection system. Now, let's move on to another important Indian standard for fire protection systems, IS 13039:2014, which covers the requirements for external hydrant systems. This standard provides guidelines for the provision, installation, inspection, testing, and maintenance of external fire hydrant systems used for firefighting operations. As shown on the left, the external hydrant system consists of a network of underground and above-ground pipelines connected to fire hydrants strategically located around a facility. These hydrants provide a reliable water source for firefighting during emergencies. In the center, we can see different types of hydrant valves. These valves control the flow of water from the hydrant system and are designed to provide quick and easy access for firefighters. At the bottom, the branch nozzles are attached to the hose line and are used to direct and control the water stream. Different nozzle types can produce jet, spray, or fog patterns depending on the firefighting requirements. On the right, we have fire hose pipes, which are used to convey water from the hydrant valve to the nozzle. These hoses are designed to withstand high pressures and harsh firefighting conditions. Together, the hydrant valve, hose pipe, and branch nozzle form the basic firefighting equipment used in an external hydrant system. Compliance with IS 13039 ensures that the system remains reliable, accessible, and ready to support firefighting operations whenever an emergency occurs. A properly designed and maintained external hydrant system plays a vital role in protecting life, property, and business continuity by providing an adequate water supply for firefighting at all times. Moving on to another important standard, let's discuss IS 3844:1989, which provides guidelines for the installation and maintenance of internal fire hydrant and hose reel systems within buildings. These systems are designed to provide an immediate firefighting facility for occupants and trained emergency response teams before the arrival of the fire brigade. On the left, we can see a typical internal hydrant system installation. It consists of hydrant valves, hose reels, piping, and associated firefighting equipment strategically located inside the building. These systems ensure that water is readily available at different floors and fire-prone areas during an emergency. In the center is the universal branch nozzle, an important firefighting component connected to the hose line. The nozzle allows firefighters to control the direction and pattern of the water stream, enabling effective firefighting operations depending on the nature and size of the fire. On the right, we can see the hose reel drum and nozzle. The hose reel provides a continuous water supply through a permanently connected hose, making it quick and easy to operate. It is particularly useful for controlling incipient, or small-stage fires, before they grow into major incidents. The internal hydrant system serves as the first line of manual firefighting within a building. When properly installed and maintained in accordance with IS 3844, it provides rapid access to water, supports emergency response efforts, and significantly enhances the safety of occupants and property. In simple terms, the hydrant system supplies water, the hose reel delivers it to the fire location, and the branch nozzle helps direct the water effectively onto the fire. Together, these components form a reliable firefighting system that plays a crucial role in emergency fire protection. Let's now discuss IS 15325:2020, the Indian standard that provides guidelines for the design and installation of fixed automatic high-velocity and medium-velocity water spray systems. These specialized fire protection systems are commonly used to protect high-hazard equipment such as transformers, cable galleries, oil storage tanks, and other industrial installations where rapid fire control is essential. On the left, we can see a high-velocity water spray system, or HVWS. This system uses specially designed high-velocity nozzles to discharge water at high speed and in a concentrated pattern. The primary purpose of HVWS is to extinguish fires involving flammable liquids and protect critical equipment such as oil-filled transformers by quickly cooling surfaces and suppressing flames. In the center, the image shows the nozzles used in these systems. The high-velocity water spray nozzle produces a powerful and directed water discharge for fire extinguishment. The medium-velocity water spray nozzle, on the other hand, creates a spray pattern that provides cooling, exposure protection, and fire control over a larger surface area. On the right, we can see a medium-velocity water spray system, or MVWS, installed around storage tanks. These systems are primarily designed to cool equipment and structures exposed to fire, preventing heat buildup and reducing the risk of fire spread. They form a protective water curtain around the equipment, helping to maintain structural integrity during a fire emergency. The key difference between the two systems is their application. High-velocity water spray systems are mainly used for direct fire suppression, while medium-velocity water spray systems are generally used for cooling and exposure protection. By following the requirements of IS 15325, these systems can provide reliable protection for critical industrial assets, minimize fire damage, and enhance overall plant safety. This makes water spray systems an essential component of fire protection in power plants, oil and gas facilities, petrochemical industries, and other high-risk environments. Moving on to another important fire protection standard, let's discuss IS 15301:2003, which covers the requirements for the installation, operation, and maintenance of firefighting pump sets. Fire pumps are considered the heart of any fire protection system because they ensure the required water flow and pressure are available during a fire emergency. On the left, we can see a typical fire pump room. This room houses the fire pumps, piping, valves, gauges, and control equipment necessary to supply water to hydrant, sprinkler, water spray, and other firefighting systems throughout the facility. A fire pump automatically starts whenever there is a drop in pressure in the firefighting network, usually caused by the operation of a hydrant, sprinkler, or other fire protection equipment. This ensures that sufficient water reaches the point of fire at the required pressure. On the right, we can see a diesel engine-driven fire pump. Diesel pumps serve as a reliable backup source whenever electrical power is unavailable during an emergency. Since fire incidents can often disrupt power supplies, diesel engine pumps play a crucial role in maintaining uninterrupted firefighting capability. According to IS 15301:2003, fire pumps must be properly installed, regularly inspected, tested, and maintained to ensure their readiness at all times. Periodic testing verifies that the pump can deliver the required pressure and flow whenever a fire emergency occurs. In simple terms, The fire pump room acts as the central powerhouse of the entire fire protection system. Without a properly functioning fire pump, even the best designed hydrant or sprinkler system cannot perform effectively. Therefore, compliance with IS 15301 is essential for ensuring reliable water supply, effective firefighting operations, and enhanced safety of life and property. For today's last topic, let's look at IS 2190:2024, one of the most important Indian standards in fire safety. It covers the selection, installation, inspection, testing, and maintenance of first-aid fire extinguishers, which serve as the first line of defense in controlling a fire. Fire extinguishers are considered the first line of defense against fire and play a crucial role in controlling a fire during its initial stage. As shown, different types of fire extinguishers are available for different classes of fire hazards. Selecting the correct extinguisher is essential to ensure safe and effective firefighting. Water extinguishers are typically used for Class A fires involving ordinary combustible materials such as wood, paper, and cloth. Foam extinguishers are effective for Class A and Class B fires, especially those involving flammable liquids. Dry chemical powder, or DCP extinguishers, are versatile and can be used on Class A, B, and C fires. Carbon dioxide, or CO2 extinguishers, are primarily used for electrical fires and sensitive equipment because they leave no residue after discharge. Wet chemical extinguishers are specially designed for cooking oil and fat fires commonly found in commercial kitchens. IS 2190:2024 specifies the requirements for extinguisher selection based on the type of hazard, as well as guidelines for location, mounting height, accessibility, inspection, and routine maintenance. The standard also emphasizes regular checks to ensure that extinguishers remain fully charged, operational, and ready for use during an emergency. In simple terms, a fire extinguisher can often stop a small fire before it becomes a major incident. However, its effectiveness depends on proper selection, correct placement, regular maintenance, and user awareness. Therefore, compliance with IS 2190 helps organizations maintain a reliable first response firefighting capability, improving life safety, minimizing property damage, and enhancing overall fire preparedness. We hope this overview of important fire protection IS standards has helped you better understand their applications and significance. Remember, compliance with these standards plays a vital role in protecting life and property. If you enjoyed this video, please like, share, and subscribe to the channel for more fire safety and firefighting engineering content. Thank you for watching.